Hello, everyone. Thank you all so much for joining us here today at the Corning Museum of Glass. Welcome to our Bring the Heat series we have here at the museum. In our amphitheater, we're doing this every week in July. So this is round 2, featuring Catherine Ayers. Everybody, let's give her a big round of applause. Assisting Catherine, we have Chris Rochelle. Round of applause. And I'm Katie. I'm going to narrate this process for you. I'm going to walk you through it. If you have any questions at all, I'll be your guide. Let me know, and I'll answer them. So we have a really beautiful piece planned for you all today to showcase Catherine's amazing skill and something that she brings to the team every single day here at the museum. So we are going to make something that she wants to make. She's designed this. She's going to make it right in front of you all. So we are going to start with a cane roll-up. Also, I just want to talk a little bit about what this is. This is being live streamed at the moment. So this is on YouTube live streamed and Facebook live streamed. So I also welcome our online guests. And if you all have any questions, thank you for that. If you all have any questions online too, please enter that into the comments and we will answer those questions for you. I will also be your guide as well. Also, I think it's on Instagram Live as well too. So awesome. All right, we have our cane roll-up. Our cane roll-up is basically going to make up the pattern of the glass itself as far as the color goes. I'm not sure if we're going to roll this on a bubble or just roll the cane up. We'll see, but we're getting things ready to go. So let's talk about glass in general. We're going to start from square one. Glass starts from our furnace at 2,100 degrees Fahrenheit, and at that temperature it moves like honey and it glows. So we have glass in our furnace there. It's a 1,000-pound tank. We've got a lot to use. And with that glass, she has covered a lot of glass with color and then pulled it into long strands known as cane. And so some of the canes, I think we have some over here. These canes are different variations of blue. So this is kind of the longer version. We pull them in really long versions. We cut them up, and then this is a longer version. We will make them into shorter versions, about this tall, about maybe, I don't know, a little less than a pencil. And with these, this is called veil cane, which means that it's all clear glass in the center. Basically, you make a cup of color and you stuff that with clear, or what in Catherine's method, which is also a great method, is the snorkel method, where you make a tube out of glass and then you suck glass from the furnace into the tube and then you pull that. So that's a very fun thing to create. Very fun method of this veil cane. So basically, if you look at the cross-section is clear glass, and then this outer layer, this kind of around the outside color, is the color out here. So we have a bit of a darker blue and a bit of a lighter blue. And so she's alternated these in a particular pattern, and then she's going to roll this up. So that's what she's doing over here. I guess Chris over here has the pattern of cane. He's going to heat that up and melt those together so that when we roll this up, it'll move as a sheet. And then Catherine is going to roll it up on the collar. So she over there is creating a collar of glass from the furnace glass. So she gathered that out. She popped a bubble in it so we don't have anything off the end of the pipe. What's off the end of the pipe is going to be the cane. So we remove that. Then we pull that layer of glass around a bit to a particular width. Now the width is measured by how long this roll-up is here. So we have this thing right here. It's called a pie divider. We measure how long the roll-up is by this, and that tells us how around the collar needs to be, how the circumference of the collar. So this is a really great tool to use. So I'm just checking in. I'm also going to be helping the team too, so I might trail off for a moment. So there's our cane. You can see it in the camera view a little bit. The alternating colors won't really be revealed until the piece is totally finished and out of the oven tomorrow. But you'll maybe see a little bit of it. When glass is hot, it looks different. So anything that has glass color in it will always look different when it's hot. Even clear glass looks yellow and orange when it's hot, but it's in fact clear. So she's got that collar. We're measuring now. This is Jesse Rossett. He's going to help us out. We also have our team of our AV team here, Emily and Conrad. So he's going to measure that, make sure that that's right, and we roll this cane up. We've got one shot, so we want to make sure that everything is the right diameter. Chris will bring out the cane when it's ready. We have to slowly heat this up so the whole thing is even. If you really heat it up too much, it'll stick to the plate, and then we can't take it off the plate. So we want to heat it up, turn the plate, make sure it's all even, and then when we roll it up, it should roll up really nicely. All right, so he brings it back. He's going to squeeze the cane a little bit. This melts it together a bit more, so it kind of welds it together, fuses it together a bit more. And then we'll roll it up. So these two will chat about this. She's the gaffer, which means she's the one in charge. She's going to call the shots. So she's looking at this, and she trusts Chris, though. These two have been working together for a long time, about 15 years. And so he's using this torch. That's an auxiliary torch. We call it the bench torch, to torch the area, the middle there, that's going to be a little less hot than the rest of it, so it evens out the temperature. And then we'll roll it up. So she's got the collar over there ready to go. And then when she brings it out, we'll attach it. Hot glass sticks to hot glass. We're going to rely on that to roll this up. Any questions so far? Yeah. Good question. The two pieces have to be the exact same temperature? Not so much. Not really. Yeah. We don't want that to be overly hot. And if this is too hot, we'll distort the collar when the cane gets rolled up, so we don't want that to be too hot. But accurately matching temperature, not so much. Yeah. But not too hot, not too cold, right? Right in the middle. Good question. What's that? It's two different blues. Yeah, the cane is alternating blues. So it's like light blue, dark blue, all the way across. Mm-hmm. Yeah. And sorry, what's that? Just to squeeze it? Yeah, those are called tweezers. We have lots of tools that we use here on the hot shop because we can't actually touch the glass because it's very hot. Does that make sense? Was that not your question? The what? The tube that we're using to hold the glass? Those are pipes. Yeah, so she's got a pipe there with a bit of glass on the end, and she's going to blow the bubble into the piece that she wants to make once she rolls it up. But here comes that roll up. So she'll bring over the collar, and she'll stick it on the side. Look at that, perfectly rolled up, nice temperature. You see how gummy that was? It moved really nicely. She'll seal that end up, but first she's going to brush off any of the extra kiln wash on that from the kiln on the side of the cane, and then she'll bring it over to the oven. I think she deserves a big round of applause for a successful roll-up. Awesome, thank you so much. So now she's gonna work on zipping up that seam. So we want that to look as if it is not the seam. We want that to blend in and look like just the rest of the entire piece. So that, we'll stick that together. No big deal. Quickly, easily, nicely done. And now we're going to work on getting this into a nice bubble. So we have this open face, kind of cold bit of glass. We're going to work on getting this into a nice round hot bubble. And then back into the furnace. So bring the heat here. It shines a spotlight on the expert glassmakers from our hot glass team, and it showcases their creativity and expertise. So it's something that we're really excited about doing here at the Hot Glass Show in the summer. We did it last year. We had 4 or 5 of us. We went last year, 4 or 5 of our artists here on the Hot Glass Show team did that last year, and 4 are doing it this year, all fitting into the month of July. And the pieces that we make during these moments, during these live streams and these shows, gets sold in the gift shop. So you could purchase this after seeing it being made. And any of the proceeds that are from this object being purchased, goes to supporting the Hot Glass Show. So it goes to supporting our programming. So that's really amazing, and we're excited to always be a part of that opportunity. So she's starting to roll that glass on the table, get that into a little bit more of a concise bit of cane. We want to make sure, again, everything's really even, and all those canes fit in easily throughout the whole entire piece. She'll go into a reheating chamber. That there is 2,100 degrees Fahrenheit, and at that temperature, glass, it's a really good temperature for reheating glass. It's very similar to our melting furnace temperature, but our melting furnace melts the glass. Our reheating chamber does not. It just is an empty chamber we can go in to reheat the glass in. She's going to use the jacks now to squeeze a little bit further, just gently squeezing as she rolls the pipe back and forth. And that helps close any seams in the cane roll-up. And eventually she's going to squeeze the end to where it closes off the bubble. So she's going to close that off in just a little bit. Any other questions at this time? Everyone's doing all right? Yeah, up here. Go ahead. Sure. How are you getting the camera shot? I'm so glad you asked. The camera shot isn't brought to us by a special camera, instead by a special window in the back of the oven. And that window is made of a type of glass called fused silica, and it melts at 4,000 degrees instead of 2,000 degrees. Yeah. So it sits in the back of that oven, and it's basically pretty heat resistant to about 4,000 degrees. Yeah. There's a camera that sits behind it, and there's 2 little fans that blow on the camera. And we need those little fans, we've learned. The power's gone out before, I think, and one of the fans didn't turn back on and the camera melted. So both fans, yeah, is necessary for that, yeah. But yeah, fused silica. Fused silica is a really wonderful type of glass. It's also been used for NASA's space shuttle. So the Orion missions, the Apollo missions, it's on the International Space Station. So yeah, very important piece of glass. And in our humble little hot shop here, the museum. She's working now to close off the bubble. She'll squeeze that together, and that closes the end off so that we can make this into a nice shape. Sometimes we save that little end. I don't know if she wants to. She's going to. She really wants to. Good, good. Sometimes Catherine makes little magnets. I mean, it's just, why not? Why not use it? So she'll cut that end off. Jessie graciously will deliver that into our hot annealing oven to slowly cool that glass. Every piece of glass ever made has to be slowly cooled in a process known as annealing. That annealing oven is at a high temperature, around about 950 degrees Fahrenheit. We'll take everything that we make and we'll put it into that oven. And then at the end of the day, we'll slowly cool on a computerized slow cooling process. And it depends on the thickness of the material as to how long it cools down for. So for the pieces that we make today, this piece might be a little thicker. This piece is going to have extra things on it. We might cool it for a little bit longer, but generally 12 to 24 hours. Let me tell you a little bit more about what we're making. So we're making this, we're making a vessel. And the vase shape that Catherine's been kind of talking about is going to be a taller shape, and the top will kind of come to, not necessarily an opening, but it will kind of come to I don't know what to call that, kind of gumdrop shape is what she's thinking. She doesn't know if it's going to be taller and more slender towards the top or more squat. So we're just going to see how that goes. And then we're going to add these beautiful flowers that Catherine's been working on. The flowers that she's been working on, this is kind of one that she made in the very beginning. These flowers, the color that she's used for this, a lot of times glass makers will roll on glass color like frit, which is little granules of crushed up glass. It'll stick onto the surface of the material and melt in. That's a good way to add color. You can also add it in powder form by sifting it onto the top, and it makes kind of a texture too if it doesn't melt all the way in. Catherine didn't want to do any of that. What she wanted to do was make basically like a blank of color. We call them a rondelle. A rondelle can be used for many things, also windows and things. But basically she made a flat disc of glass with different colors added and then broke these discs into shards like this. So she took, this is more of a disc there. She takes it and she just drops it on the floor, breaks it into these shards, and then she'll pick up each shard on the end of a punty, on the end of an iron, one of these rods that we shape glass with, and then she'll make it into a leaf or make it into a flower petal. So that's a really smart way to do that. You can see some of the color pattern in this piece here. We've got some kind of light and dark areas of blue. The lip is a little bit darker than the rest of it. Here's a really good example of that color difference. This looks like a nautilus shell. You can see how she shaped that just with the rondelle. She shaped the color in that rondelle. So then she took those shards, made those pieces out of it. So she's got lots of flowers and leaves in that sort of way. I think she has some flowers and leaves over here too. Some of these leaves these are really cool. And of course, if you want to come over after the show and look at these a little bit closer, these are some of the leaves that she made from that. So you can see that color really well in this piece. Awesome. All right, so she's drawing on the whiteboard. Thanks, Catherine. A little bit more about what she is going to be working with. So we're going to attach those flowers around the piece. I think she has 3 big flowers and then leaves to go along with that. So very exciting. That's what we're going to make today. Right now, we're going to work on getting this bubble in a state to where we can gather over it without trapping any bubbles. When you take round pieces of cane and you roll it up like she has, and then you try to gather over that, the round pieces of cane, in between them is a crease, right? And if you go into the furnace, in our big furnace, I can't roll the gathering animation, but there's a big bowl of glass inside of our furnace. It's called a crucible. And you dip the glass beneath the level inside there, and you turn it one direction, you gather out an extra layer. And if there's ridges on your bubble, when you do that, you're going to trap bubbles when you cover it with that extra layer of glass. We don't really want to do that. I guess you could if you wanted to, but we don't want that. We want to smooth the sides out by rolling the glass on the table or using the paper to cool and shape the glass. So she's going to work on smoothing that out. Look at it now. It's a hot, gooey bubble. It looks very different than what it just did when we were rolling that cane on and evening it out. But now we're going to use that block tool a little bit more. Jessie's going to help inflate if she needs it. That tool that she has in her hand right now is called a newspaper pad, excuse me. That pad of newspaper has been soaked in a bucket of water for about 10, 20 minutes. We squeezed all the water out, and then we started to use it. It works really well. Newspaper works so nicely because it has, it's flexible. We can start to use it against the glass in kind of a unique way if we need to. Use the palm of our hand to shape the glass. But it's so dense, those fibers in the newspaper are so dense, it doesn't transfer heat to our hands. Any of the heat and steam from that paper stay on the top layer, and that keeps us from feeling any of the heat. It's a great way for us to squeeze the glass and shape it with that. Then back into the furnace. So a little bit of back and forth. Jessie's helping out still. Just smoothing that out. Any other questions out there? All right. You just let me know. I'll answer them. This table here is called a marver, which is a French derivative of the word marble. So this traditionally is made from stone. But these days, it's a little bit more, it's a little bit cheaper to buy steel. It works a little bit better. But you can roll that glass out on that table. She's going to get this shaped up so she can gather over it. So we'll put at least 1, if not 2 layers of glass over this bubble. This is already good size to be gathered over a few times. The furnace that we have, our glass in, is at 2,100 degrees Fahrenheit. To put glass into the furnace, we buy it from a manufacturer that makes it from Glasma, which is the company we buy it from. That's the company that makes this. This is what it looks like. It's called batch. Batch is the raw ingredients of glass. It's silica sand, soda ash, and limestone mixed together in their particular proportions and then put into the furnace. We shovel it into the furnace. We spend a whole day doing that. And then we fill it up once it's full. We let it cook. The next day we come back and we can gather glass out of it. So it's really easy to charge the furnace. We use batch for that. So the type of glass that we work with is called soda lime glass. That's the most popular glass that we use in the world. So that's also our consumer glass, like windows and jars and bottles, things like that. The glass that we use, the Glasma, is formulated so that we have a longer working time here as artisans, as humans. Machine-made glass, like windows and jars and bottles, it's formulated to set up a lot faster. So that glass is not compatible with what we use here, but they're in the same family of soda lime glass. To add color to the glass, to change the color of the glass, you add a metal oxide to the material. So if you want cobalt blue, what metal do you think we add to make cobalt blue? Cobalt, yeah. We add cobalt to it. We add copper to make a light blue. Manganese will make purple. Gold chloride makes a pink. Any metal you can think of, cadmium, selenium, titanium, will always change the glass color. So for this piece, we have lots of silver went into these blues. Silver also can make blue. Probably some, let's see here, probably some silver. Oh, wait, look, she's going to go into the furnace. She dips that glass beneath the level. She turns in one direction. She's going to bring this glass out. Look at that gooey gather of glass. Isn't that beautiful? She's going to bring it back to the workbench, shape and cool the material with a wooden scoop tool called a block. This will help us even that gather out right immediately. It's a nice even gather, but it's not perfect like how we can make it with the tool. So we want this tool there to assist us in making that even. So that's cherry wood. We keep it in a bucket of water. The cherry wood blocks are carved still green so that when they are soaked in their buckets of water, they can stay soaked forever. Chris is going to help her turn the pipe as she starts to shape this. Just team-oriented craft, it really is. Glass making is very much so team-oriented. It's possible to do it alone, but it's better with a team. Good question from online, right? Does the hot glass show team ever use borosilicate? We have a flame working demonstration that we do every day. It's actually the longest demonstration we've done here at the museum. We've done it since we opened in the 50s. So we do use borosilicate. We don't use it in our hot glass show studios, in our furnace studios, but we do have a flame working demonstration. And here on our floor, actually I should say, here on our floor we have had borosilicate demonstrations. We have our Flame Collab every single year. That happens. It used to happen in February, but I think we're going to start it in June. We did it this past June. So we do have flame workers that come here and work on our floor once a year. And then Caitlin Hyde, one of our glassmakers, our Hot Glass Show team resident glassmakers, she works on our stage sometimes. She's done a few live streams. Check those out on our YouTube channel. Eric Goldschmidt, our resident flame worker, also does those as well. So we have done some borosilicate. Yeah, good question. All right, I think we're going to go right into shaping. I don't think we're going to get another gather. I think this is going to be plenty of glass. I think that she thinks it's going to be plenty of glass. It's up to her. She's going to start to shape this. She's using the newspaper again. And then she's starting to inflate the glass. Jessie will inflate it for her as she's shaping the side. And they roll together at the workbench. right, so they're thinking about the next step. We're going to go into our reheating chamber to reheat it again. And then we're going to start to work in the neckline. The neckline is one of the most important moves. We want to make sure that we get this piece removed from the blowpipe. So the neckline, the jack line is another name for it, is a line in the glass where we're going to break it off later. So that needs to be there. But sometimes it also can help inform the shape later too. So depending on what she does here, we'll see. She'll bring it back to the workbench. I'm sorry, Chris will bring it back to the workbench. Now, Catherine will start to squeeze a line into the glass near the pipe. And so that's going to be the start of the neckline. We're aiming the glass towards the ground, which is elongating the glass, making it taller. So she's using the fluidity of the material, just naturally using gravity to elongate the piece. Very nice. She'll squeeze that again. The jacks are a stainless steel tool. The blades are lined with beeswax. Or else you kind of heard a little bit of a screech. That would we'd be hearing that quite a lot without that beeswax. It could scratch the glass too. So back to squeezing that line in. And we have Declan here shielding Catherine's arm. That really helps when you're making the neckline. We have delicate skin here, humans, we do. And when we're above that hot glass, it kind of gives us a little bit of some pain. And so Declan's there shielding her arm with the board. And that definitely matters. We can protect ourselves in those times without an assistant. We can put on Kevlar sleeves or gloves in those instances. A lot of times we get questions, why don't we wear gloves? We simply don't need them. We don't touch anything that's hot. But while we're working with the glass in those instances, when it's a larger piece of glass, when we know we're going to be close to the glass all the time, we'll put a glove on for that. It really depends on personal preference. It depends, honestly, we never do things that make us uncomfortable. So if we ever are uncomfortable, we'll put a glove on. She doesn't necessarily need a sleeve right now. This isn't a large piece of glass. I mean, it's a really nice, amazing piece of glass. It doesn't need to be large. But when the piece is very large, it radiates more heat. So that's what will add more protective gear on our arms and our hands. We do wear cotton clothing that keeps us safe and safety glasses. Then back to the furnace. We're going to use the newspaper again. She'll get some assistance with turning. You can see that the bottom is a little hotter than the rest of the piece. That's where it's going to move when they inflate it. And that's what we want. We're shaping the bottom up right now. She's going to work down the vessel. That's mostly how glassmakers will work. They'll work down the vessel, then flip it over and work down it again. So once we have that neckline established, we'll start to work down farther. And then the ending, the end of this, of course, is the bottom of the piece. We'll flip it over and finish the top. And then we'll add all of our flowers and our leaves on for the piece. Right now she's emphasizing heat on just the bottom. And she'll drop it out, holding it down again, elongating the piece. The glass blower makes sure that they have enough glass to do what they need. So if they want to make something big, they have to get a large amount of glass. If you are working with a little bit of glass and you blow it way up, it could get too thin. You could, when you go in the furnace, when you go back in the furnace, you could deflate the bubble. It could collapse because it's too thin. It gets too hot. And that's something that glass makers will deal with their entire career. That's something we always are thinking about. How much glass do I need to create this size piece? And it's a hard thing in the very beginning to learn. She's using the jacks to go on the side. She's being shielded, and then Jesse's blowing. What's so nice about this veil cane is that you're going to have concentrated areas of color on the outsides, and the inside you might see it blow out a little bit. I'm not sure if that's what she's going for, but I really like it when it does that. So we're going to see that a little bit. She's heating just the bottom section of this piece, and we're going to heat, or we're going to flatten the bottom when she comes back out. So we're going to flatten that right out, I think. We'll see what kind of shape she wants to go for. Declan is pressing the board against the bottom of the vessel as Catherine squares up kind of the bottom sides. And once that looks good, we're going to work on transferring the piece. Very nice. All right, so we're going to work on transferring this piece over to work on the top half. So that means we're going to create a punty. We're going to attach it to the bottom of the vessel and then break this piece off of the blowpipe. So Chris is going to start that punty process by getting a particular pipe. We want this to be able to withstand the weight that we're going to have for this piece, the piece itself, and then the flowers added to it. I don't think it's going to be outstandingly heavy, but we do want something that's going to work. So looks like he's going to use a blowpipe. We're going to make a punty from that by gathering a little bit of glass out of the oven. He'll cool it down and shape it on the table, the marver. And then he'll bring it to Catherine, who will apply it to the center of the bottom of the piece. Then we'll get the glass to break free along that small constriction line near the pipe. So Chris is going to use that bit of glass and roll it on the table, cool it, shape it. And then when it's at a good temperature and shape, he'll bring it over to her and she'll apply it. We're cooling the punty down so that when it is connected, it's going to be a weaker connection. The hotter the glass-to-glass connection is, the stronger it is. So if you want something on there that's going to be there forever, you want to bring that over really hot, or at least heat them up to the point where when they do attach, they fuse together. But this colder connection will be a weaker one, and we want that to be that way on purpose, so it releases from the piece easily without making much of a mark. If you see a handmade glass piece and you look at the bottom, you're going to see where that punty was broken free. It always leaves some sort of marking. A lot of times that can be fire polished away and smoothed away with heat. Sometimes it could be cold worked away and ground and polished away. But oftentimes you'll see a little mark where that punty was when it was being made. That's a good indicator of a handmade glass piece. All right, so Chris will reheat that punty in the furnace for just a moment. And then he's looking at Catherine. We're kind of thinking about the timing. We're getting ready for the next step. Here we go. He'll bring this over. She has a really great kind of bullseye effect there. The center of that cane is right in the middle. And then she'll connect it. that punted, we want it to be straight. We don't want it to be off, or else the whole thing's going to be off. We want it to be right in the middle to keep that same axis, so that when we finish the top, it's all going to be straight. Now, to get the glass to be removed from the blowpipe, to remove it, we're going to add something cold to that small constriction line on purpose to get it to break, to get it to thermally shock. So right now the glass is around 1,000 degrees. It's rigid. It's breakable. If you hit it with a hammer, it will break. You can also add something cold to it. It will shock it, and it will crack it. So to do that, she has a little extra heat. That always helps. And then the thermal shock is right here. It's a drop of water. She places right there and here. And on the pipe, she will tap it. And a light tap breaks it free. Let's give her a round of applause for that move. Nicely done. Awesome. Perfectly transferred. We now have an opening. That's the point. We do want this vessel to be open, to remain open. Relatively functional. We're kind of thinking of it more of being a canvas, more than it being a functional vessel, but it is going to be open. So we're going to heat the top, melt that in a little bit, shape it, and then we'll start to add our flowers to it. Yeah. How are we doing on questions? Everybody doing okay? Awesome. Yeah, great. A little info on Catherine Ayers. She is a glassmaker. She's local. She's from this area. Oh, I'll get back to that. Here's a question. Yeah, what's your question? Do the two furnaces, are they different? Yes, good question. The furnace that is open over there that we're working out of is our reheating chamber. It's 2,100 degrees Fahrenheit, but it's empty. No glass inside of it. Our furnace where we have all the glass inside of it here is full of glass. It's also at the same temperature, 2,100 degrees Fahrenheit. So we call it our melting furnace. And then we do have a smaller furnace over here. It's very similar to that one over there. So those two furnaces there are the same temperature. They're both empty, but one is just a little smaller and one is larger. We pump out a lot of energy. This is run on natural gas. So having a large oven on spends energy. So if we're going to have, we have another one over here. We don't use it as much, so we might as well have a smaller one on. Yeah, so we call it the assistance bench. So maybe a place to reheat bits or a place to make objects to go on the other workbench. Oh yeah, your question. Good question. Have we ever burned ourselves? Never. Not once. I'm kidding. It happens. It happens when we are more likely when we are just starting. So when we're not familiar with our surroundings, when we're not familiar with what can and is hot, we do burn ourselves a little bit more on accident. Of course, accidents happen. But as you gain more experience in the hot shop and as you learn from your mistakes, we get burned a lot less here. Yeah. These days. Yeah. How's someone trained to do this? It depends really on kind of what your path is. A lot of times a glassmaker finds it in college, and there are different colleges that offer glassmaking. They stumble upon it and think that looks cool, and they try it, and it turns out they really like it. That's a really common path. You can also, oh, watch this. We're going to add a lip wrap of color around the lip of the vessel. Look at that, perfectly administered. This is elephant gray, which is it's like Catherine's color. It's one of her favorite colors. So yeah, you can also become a glassmaker by just getting a job in the field. By learning from someone else, then you can kind of work your way up and learn from someone else. And then you learn a trade from that person that gets you to this job. It's kind of like becoming a chef, where you kind of learn in different kitchens as you go. And then 20, 30 years later, you have your own kitchen. Yeah, good question. The traditional apprenticeship sort of thing is these days more of a non-traditional apprenticeship, but that's how things were done for a long, long time before our modern times, was an apprenticeship where you learn under someone for probably 20 years. Yeah. Awesome. Yeah. Okay. Good question from online. Do we ever shut the oven off? Some of them, yes. We shut off our reheating chamber, the one that she's in now, and our other reheating chamber, and our pipe warmer. We have a pipe warmer that warms the pipes up so the glass will stick to the tips of the pipes. We need that. But our furnace with all the glass inside of it, we never shut it off. We just put this one in 2 years ago. We expect to turn it off in 6 years when we're going to replace it. So we want 8 full, unchanged years out of this oven. And the oven that we swapped it out with, that was on for 8 full years. So we leave that on. The reason we leave this on is, first reason, we are here every single day working out of this studio every day. And so if we were to turn this off, we would need to cancel all of our shows for a whole week. And then it takes about a day or two. Well, it takes a whole day to dump the glass out. Then it takes 2 or 3 days to slowly cool the oven. It's a delicate instrument. We want to make sure that it's slowly cooled. And then if we need to do a repair, it might take a day or two. And then to turn it back on, we turn it up slowly. And then we take probably 2 days to fill it full with our batch glass. And so, yeah, we would have to shut the furnace down, the amphitheater down for a long time. So we keep that on. Question? Oh, do we have 2 questions? Okay. What's the other question? I can't even. Oh, it's you. Okay, go ahead. Yes, it does. Some of it. So some refractory does last 8 years. Yep. In this furnace here, it's more of that castable refractory. In the reheating chamber, that's stuff that can last a little bit less, but it can last a long time. Yeah. It just depends on the use of it. What's that? No. No. So it's basically, it's in a metal container, and then the brick's on the inside of that metal container. Yeah. Metal surrounds it. Yeah. We do look at our equipment almost daily. We address it, anything that needs to be changed. But yeah, we hope it lasts as long as we can take care of it. Yeah, no problem. All right, go for it. Yeah. It totally is very important. Yeah, the question is, how do we control all these variables with all this different equipment as far as temperature goes in annealing and things back in the day without our modern technology? So one of the things that basically the fuel they were using was wood fire back in ancient Roman times and leading up to about maybe the 1400s, 1500s. So they were using wood fire. To control the temperature, they mostly looked at the color of the furnace. So if you look at that furnace color, it's a bright yellow, and that's 2,000 degrees. But if you look at the pipe warmer color right there, that's a dim red, and that's about 1,200 degrees. We know now because we have our thermometers attached to it. But back then, they would look at the furnace and realize that that's not as hot as I want it to be, because last time we worked at this particular color, the glass wasn't moving as much. So it all also kind of evened out to be this 2,100 degree temperature, where the glass is really gooey too. As far as annealing goes, so basically to blow glass, you needed a wood fire furnace, which is a furnace made of clay and daub, and it's kind of curved on the top so that the heat can kind of convection around. The inside would have a bowl of glass, and then you'd have your fire underneath that. And that's where you would blow glass. You would gather your glass out of it. You would use the same opening to reheat the glass. It was all kind of one little thing. To slowly cool the glass, which is required for every piece of glass, a small oven would be made off the side of that furnace where that heat source is. And then you would put the glass that you made near that heat source where you know is a sweet spot to start out, right? Again, trial and error. And then you would slowly move it away from that hot spot to anneal it. So slowly walking it away from the heat was literally what they had to do. I like to call it manual annealing. Yeah. But there's, of course, been a lot of changes to glass as far as working with it here, melting the glass, turning it, shaping it, using gravity, things like that. That hasn't really changed. But the technology that we have been using to heat the glass and anneal the glass, that has been changing the most of all things. That's a great question. I'm so glad you asked that. Look at this. We're adding on our beautiful flowers and leaves. Again, the color's going to be a little different, but I can tell you that that flower is pink. We made that one today. And then the leaves that are on there right now, I think, are that teal blue. This is all opinion. I think it's this one. So that beautiful blue is going to look a little green when it's hot. And she's got the flower right on top of it. Now, Jesse's in charge of holding that pipe right now, so he's going to make sure that that stays on center. Have you noticed that when he flips it over, it's a little off? It's a little kind of like this when he moves it. We're doing that, or that happens because the punty's a little hot, which is kind of what we want. We want it to stay hot. But when we stop turning, it'll start to fall. Jesse's job is to then compensate the other direction and let it fall the other direction. And his main job is to keep the piece from breaking. Like I mentioned, if the glass gets too cold, it will crack and it will break. So he's got to make sure that all these variables keep the glass nice and warm while Catherine's working. She's going to focus on creating the piece, on adding all these little bits and pieces to the vessel, all the flowers and the leaves. And then also Chris over here is going to bring all those over to her. So everyone has their job. My job is y'all. So if you guys, again, need me, let me know. But a team is really required for this type of glass making. All right, so he goes in, and if it's too hot, Jesse's going to not heat it so much. So that's all you have to do is just heat it a little bit less if it's too hot. Keeps making sure that the form is centered and even. I'm just going to check on you. Doing okay? Yeah. Okay. I'm going to check on Jesse, too. How are you? You doing okay?
Beautiful. Thank you.
Okay, good. You doing okay? Good. Oh, that was fun, huh? Oh, good. Oh, good. All right, everyone's good. So there's a lot of back and forth. There's a lot of reheating in the furnace, keeping it from getting too cold, and applying glass. So it's a bit repetitive, but this is what we do to create these amazing works. She's been thinking about how to decorate this, where to put the flowers. She's been thinking about that a lot. So she's finally rested on this pattern, which is, and all of her ideas have been great. But this is her final resolution. Okay, lots of coordination. Chris is going to bring over some things, and also it's an order. So she set up an order of which pieces go on next. So the garage over here is this piece of equipment. It's a really important piece of equipment for what we're doing. She's made all these beautiful, delicate flowers, and she puts them in the annealing oven to slowly cool. Then they're out in the open air. We can hold them just like this one. And then to get them to a temperature where they can be put onto the glass, this has to be brought up to 1,000 degrees again. And we have a larger piece, which is more fragile. So we want it to be brought up slowly. So what we do is we put it into the garage. The garage, we can heat up slowly. And this side of the garage over here is around maybe 1,050 degrees. And then this side over here is maybe around 950 degrees. So what we can do is put the glass in here, bring it over to this really hot part, and then go from 1,050 degrees right into 2,000 degrees. The jump from 900 to 2,000 is too high, but from 1,050 to 2,000 is better, is pretty safe. So that's what we do. So all the pieces that we have that she wants to put onto the piece are in the garage. They're in a particular order that Chris knows, and he knows exactly what to bring her next. So it's choreographed. We've thought about this. And this team works together really well. Like I mentioned, they've been working together for a long time. All of us here on the Hot Glass Show have been working together every day for a long time. So we're very well-versed in working with one another and communicate well. All right, so she's working on another set. So I believe that that is some more leaves. And back to the furnace again. Now Jesse's setting that puntee down really gently so that he doesn't hit it too hard, because that will make the puntee release from the piece, or the piece release from the puntee, I should say. So he's very gentle when he brings it back to the workbench. That's why he goes so slow for a second. Make sure that that stays on the puntee. Yes? How much would a piece like that sell for? I'm not sure, but we are going to sell this. So after this is out of the oven, Catherine's going to look at it. She's going to assess. She's going to decide on a price, and then it's going to go for sale in our shops here at the museum. So stay tuned. That question can be answered in a couple of days. But yeah, I'm not sure what she'll put on as a fair price. Yeah. Yes? How many shows do we make a day? During our regular show schedule, we have about 11 shows here and about 11 shows upstairs in our innovation stage. So that's 22 shows a day. This one is going to take over 2 of our shows. So today down here we only have 9 shows. But that's only for today. The rest of the days it's 22. Yeah, it's a lot. So that seems like a lot. But sometimes when we make production, if we're making, let's say I wanted to make ornaments and I wanted to do it for all day long, I could make 200 ornaments in one day if I really worked hard. So yeah, it depends on what you're making. Ornaments are a lot less time consuming. They're really fast. But sometimes also, if I wanted to make a really elaborate decorative piece, it could take me 8 hours if I really add lots of details to it. Good question. Yes? Yeah, if you have an 8-hour piece that you're working on, do you take breaks? Yeah, we're humans. We get hungry. We have other things we have to take care of. What do we do with the piece? So most likely we'll stagger. So if we're going to have like a quick lunch break, we can do that here if we need to. It's rare. But this would be like a private studio sort of thing. Someone would say, hey, can you please watch the piece? And they'll spend maybe half an hour just flashing it, which means just reheating it briefly to keep it from getting cold. It's not the most fun part of the day, I'm sure. But then when the group comes back, that person can then go eat some food and come back. So if those 8-hour pieces do happen, it would be something like that. That would be grueling without a break. Yeah. Yeah, definitely. Good question. Yeah. Yeah, I'm glad you asked. When this piece is finished, do we post any photos about it? We will post extensive media coverage about this, yeah. So this is being live streamed right now through social media and through YouTube and things and Facebook. When this piece is finished, this is also going to be posted again on our social media too. So we're going to do some videos about it and stuff. And then I think, on our website for sale, and then we'll do like at least a couple of posts just showing a picture of it too. Yeah, so you'll get to see it. So if you're not watching, or if you are watching online, you'll be able to see that too on our website and on our social media. Yeah. Yes. Good question. Can we take a piece, cool it down slowly, take it out, and then heat it back up again and work on it? Technically, you could, but it's very risky. So let's say it's a piece like this. So what I'm holding is a pitcher with a handle on it. If you want to put this back in the oven to heat up, you really want to heat this up slowly, maybe over the course of like 4 to 8 hours or so. And then you're going to have to hook a puntee to the bottom of this and take it out. And keep it turning, and it's a little risky. So if you're going to make something or if something is wrong with this, just make it again. That's what we would do. If there was something wrong with a piece that took us 6-7 hours to make, then again, you could lose all that work, because if you take it out and it breaks. So generally, no, we don't really do a whole lot of that. And that's kind of a all over theme from most glassmakers, is we won't do that. Because it is risky. It's too risky. Yeah. Yeah, you have to fix it and make sure it's good here before you put it away. The things that you can do to it cold are mostly in the cold shop where you can grind away things. Like let's say you put this away and it kind of rocks a little. You can grind it flat on a flat wheel and that will flatten it. That's kind of, you know, or like let's say this part touched back and there's like a string. You can kind of like Dremel that off a little bit. But otherwise, yeah, make sure it's perfect here before it goes away. Say what? We grind it with diamond embedded wheels on a motorized. It goes around and around. Yeah, diamond wheel, or like a belt sander with diamonds encrusted in that too. Yeah, yeah. Diamond's the only thing that'll cut glass, so grind it with that too. And sometimes a stone, like a stone slurry, will help grind it too. Yeah. Awesome. Good question. All right. Oh, I also want to mention, if you're working on that 8-hour piece, you can also put it in the garage to keep it warm while you go have your break. I forgot to mention that part of that question. That's rare, though, but possible. All right, let's check in. We've got almost all of our flowers on. I think we have one more flower to add. It's loaded up. Chris here has a couple more leaves that are going to go on. We are slated to end at 4:30, but we'll keep going if we need to till a few more minutes. And every time Catherine grabs one of those leaves, she's using a torch. That's a 4,000-degree torch. And she's using that torch to superheat the bottom of the leaf so that when she sticks it into the vessel, it melts in and it fuses in, and it's there forever. Your question up here, go for it. Oh, can you use your outdoor voice for me? Go ahead and shout that out. Can I get a translation? We got. Anybody else hear that question? Has it ever exploded? Oh boy. No, it's never really exploded, but it can fall and crash and break, you know. Yeah. Exploding doesn't really. Yeah. Sometimes if you have a bubble and it's closed off and you heat it, that can expand, but it won't explode. If it drops, it'll explode on the floor, yeah. But we're going to not hope for that at all. We're going to just sweep that one under the rug. But yeah, no, for sure. It does sometimes. Only if we drop it. Only if we drop it. And do we drop it? We try really hard not to. But we're not perfect. But Jesse's perfect. He's not going to drop it. That's how we get by. This is one of our last flowers. This is a beautiful poppy. Look at that. Isn't that amazing? She made that just a few days ago. And again, she used these really cool rondelles to make the leaves. So this is for the leaves, this color for the leaves. And then these rondelles. Where's the other one? To make some of the petals. I guess that's all. She must have used, oh yeah. So you can see some of the colored variances in this. Very, very nice. Okay, we are nearing the end. We're going to make sure everything looks perfect on the piece before we put it away. Question up here? If glass falls on the ground, do we throw it out? If it has color in it, we can't reuse it. So yeah, we'll throw that out. But throwing it out for us means we give it to the city and they'll reuse it. So they'll find ways to reuse it. If it's clear glass and it hits the floor, we can throw that back into our furnace. If it's clean, we'll recycle it. Yeah, good question. Good question. All right, so we're getting ready to put this into our oven. The oven we're using is that one that says hot, 960 degrees. So we're going to put this away into the oven to slowly cool. Declan is going to put on some personal protective gear, some Kevlar gloves, a face shield, and our silver suit. That really keeps them nice and cool. We're going to hold the glass in our hands. So they're going to put on their Kevlar gloves. And then we're going to put it into the oven. We're going to get everything nice and centered. We're going to make sure every leaf is touched down where we want it to be, every flower petal where it needs to be. We're going to even out the heat, too. All very important moments. Wow, that poppy looks so good. Those look awesome. So again, this will be for sale in the shops in a few days. All proceeds from the purchase of this piece will go to support our programs here at the museum. So keep that in mind. Keep an eye out for this. All right, we're going to put this into the oven. Declan's going to stay underneath the piece the entire time. And she's going to add a drop or two of water. The water is going to thermally shock that small constriction line, or that small connection point between the punty and the piece. And then a light tap will get that to break free. And I'll bonk. And that will break. Nicely done. We're going to fire polish that disconnection point with the torch. Then it'll get put away into our oven. He's going to walk very carefully into our annealing oven. Set that down safe and sound. Let's give it up for Catherine Ayers. Keep it going for Chris Rochelle, Jesse Rassad. We've got Declan. We've got Emily. We've got Conrad. We've got Brad up in the booth. And Jason is around as well, helping out too. Thank you all so much for joining us today. That's going to do it for our Bring the Heat edition number 2. We have 3 and 4 coming next week and the week after that. Stay tuned. YouTube, Facebook, Instagram Live. Enjoy your day today. Thank you so much.